This is build log 2. We're still trying to make an omnidirectional treadmill, and so far we've had minimal progress, but we are getting somewhere, so let's hop right into it. I've already made quite a few purchases such as belts, ball bearings, and other things like dowels, and I've already made quite a few mistakes in this project, so please make sure to support me by liking, subscribing, and sharing the video with friends and family. And without further ado, let's get on with the video. Now, if you don't remember it, this was one of the gear reductions or belt reductions we were working on last episode, and I was able to 3D print this and make a small model to see how it might work. So here it is. It has a 7:1 gear ratio, as in the small gear has to spin 7 times for the big gear to spin once. Now, I'm also working on reprinting the biggest gear so that it meshes correctly with the teeth, because as you can see right now, they're inside out. Now that I knew that worked, I started work on the main treadmill design. Now, after about 3 hours of fiddling / making things, this is where I'm at. I've got our teeny tiny gear reduction right here, which really shows you the true scale of this treadmill. Right now it's sitting at 4 feet by 4 feet, and basically this gear reduction will then spin this. It'll go about 1 foot a second just for the first prototype before I blow like $150 on motors. And then you've got this thing in here which will move the belts this direction. Now, I haven't figured out how I'm going to power this yet. I'm going to have to use a second motor, but basically it's just going to rotate all of the belts that it comes in contact with, which should be about these 5 or 6. And yeah, hopefully that should work. So now let's get to work on actually making these individual belts. So already I've ran into our first problem. This board that supports the belt needs to be able to support at least 300 pounds. Now I could just make it out of 1/2-inch plywood and call it a day, but then it's gonna weigh like probably 100 pounds for the whole entire belt itself, which is pretty unacceptable. So then I looked online and I found this honeycomb plastic composite, which can also support roughly the same weight but weighs a ton less. But the issue with that is that shipping was over $200 while the product itself was only $75, so that's not gonna work. Now I could test which material would work best for this board underneath the simulations tab in Fusion 360, but I'm actually unable to do that until I subscribe. Currently I'm using the free version, and to get it, it costs over $60 monthly, which is just out of my price range right now since this is an unfunded project. So we'll have to come up with a different solution. Now, although wood does weigh a lot, I think we're just going to go with some 45-pound hardwood that's 1/2-inch thick, because it's the only cheap option that's actually viable for this project. Now that we have that figured out, let's hop back into Fusion 360 and figure out the belt design. Alright, so after that, the main belt turner is now in the center, so that'll handle lateral movement like this. And then I've got 3 rollers here, which will be made of a slippery material so that the belts don't catch on them, but it's so the belts can easily glide over this direction. Now I think we've made pretty good progress for the day, and I think I'm going to call it here for build log 2. I really hope you guys have enjoyed today's video. Make sure to like, subscribe, and share the video if you want to. And I'll see you guys later.